Okay, hello everyone. In a new video. On this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2010, second session, first exercise. So the title of this exercise is Role of a Lens. The document below, they mentioned the document. So now I can use it. Shows the ray diagram of a luminous object AB placed perpendicular at A to the optical axis x prime x of a lens L, and ray BI parallel, an incident ray BI parallel to x prime x, its corresponding emergent ray IR, and an arbitrary incident ray BJ. So number 1, nature and focal length of L, part A. They are telling me that L is a converging lens. Why? So we can determine the nature of a lens by checking how does it affect a ray of light. So BI is an incident ray because it's hitting the lens, and IR it's emergent ray because it's coming out from the lens. So BI is supposed to complete its path like this, and as we can notice that the emergent ray emerges toward the optical axis, and which means that the used lens is a converging lens. Okay, so let's say that since the emergent ray IR emerges from the lens L, toward the optical axis, which means that the lens L is a converging lens. And now in part B they are telling me specify the position of the image focus f prime of L. We know that always the position of the image focus is related to an incident parallel ray. So BI is the incident parallel ray and IR is its emergent ray. So the intersection of this ray with the optical axis will be the image focus f prime. Then let's say an incident ray issued from B parallel to the optical axis emerges passing through the image focus. For this, then the image focus f prime is the intersection of the emergent ray with the optical axis. And now in part C they are telling me determine the focal length of L. So now we know the position of the image focus and we already know the position of the optical center, so we can calculate the focal length by referring to its definition, which is given by the focal length is the distance from the optical center to the image focus. So the focal length is the distance from the optical center, which is the point O, to the image focus, which is the point f prime, and we don't forget the bar because this distance may be positive or negative. So f is equal to O f prime bar, which is the distance from the optical center to the image focus. Notice that this distance is in the same direction of the positive x-axis, so it's positive. And now we count the number of divisions between O and f prime. We have 1, 2, 3. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give us 6. Since the scale is in centimeters, then the value of f will be in centimeters. Always, all quantities in physics must have a unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. So the focal length in this case is positive, which confirms that the used lens is a converging lens, because we know that for a converging lens the focal length is always positive. So now in number 2 they are telling me construction of the image. Let me make some space. So now we are in 2 part A. They are telling me redraw the above diagram using the same scale and place f prime on the diagram. So the direction of propagation of light is from left to right, and whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. Then we place the lens L perpendicular to the optical axis at the center. Now, because we know that the lens L is a converging lens, so we use the convenient symbol of a converging lens. And this is the lens L. Now the intersection between the optical axis and the lens L is the optical center O. Moreover, the point A is located on the optical axis, 1, 2, 2 divisions in front of the lens, so 1, 2, this is the point A. And the point B is located 1 division above A hat is found on B. Now let's trace the object AB. Now the point I is located 1 division on the lens upward, so this is the point I. And the point J is located 1 division downward on the lens L, this is the point J. And so BI is an incident luminous ray, and BJ is another arbitrary luminous ray incident on the lens L at the point I. And we don't forget arrows on light rays that indicate the direction of propagation of light. Now the emergent ray IR intersects with the lens L at the image focus f prime, which is 1, 2, 3 divisions behind the lens. And they told me place f prime on the diagram, so 1, 2, 3, this is f prime. So this is the emergent ray IR. Moreover, the scale is given by 2 centimeters along the x-axis and 2 centimeters along the y-axis. So this is it for part A. Now in part B they are telling me trace the path of another particular luminous ray issued from B other than BJ and determine the position of the point of point B prime, the image of B. So they told me determine, which means we need to trace and justify at the same time. So we need to trace the path of another particular luminous ray issued from B other than BI and determine the position of point B prime, which is the image of B. So because they told me to determine, we need to trace and justify. So we need to trace this ray and justify it as well. And we need to trace the image B prime and justify it as well, using the path of another particular luminous ray, okay, other than BI. So here the easiest one that we can consider is passing through the optical center. And we know that this ray will emerge without deviation. So now we have done the tracing of this ray. Now let's do the justification. So now we are in part B. Okay, an incident ray issued from B passing through the optical center. Emerges without deviation. So we have done the justification of the ray. Now we need to trace and justify the image. In order to trace the image, we require that the emergent rays must intersect. But notice that these two emergent rays, they don't intersect behind the lens. Therefore, we need to prolongate them backward. So this is the prolongation of the first emergent ray, which is parallel to the optical axis, and this is the prolongation of the second emergent ray. This is the second emergent ray. So this is the prolongation of the second emergent ray. And this is the point of intersection of the prolongations. Okay, so this is the image of which object. Notice that these prolongations are corresponding to these emergent rays that are coming from these incident rays that are coming from the point B. Therefore, their point of intersection will be the image B prime of B. The image is denoted by B prime. Moreover, a hat is found on B directed away from the optical axis like this. Then we must place a hat on B prime directed away from the optical axis like this. So let's place the hat. So now we have done the tracing of the image B prime. Now let's do the justification. So what does the point B prime represent? Then the image B prime of B is the intersection of the prolongations of the emergent rays. So we have done the justification. This is it for part B. Now in part C, they are telling me construct the image A prime B prime of AB. Okay, and the word construct means that we need to trace and justify. So the image A prime B prime consists of 2 points, of B prime and of A prime. So we have already done the tracing and the justification of B prime. Now it's left to trace and justify A prime. So we need to trace and justify A prime. So A prime is the image of A. So notice that the point A represents the foot perpendicular of B on the optical axis. Then the point A prime will represent the foot perpendicular of B prime on the optical axis. So this is A prime. And now let's trace the image A prime B prime. So because B prime is the intersection of the prolongations, then A prime B prime will be dotted. So this is the tracing of the image. Now let's do the justification. So we are in part C. A prime is the foot perpendicular of B prime on the optical axis. So now we have reached part D. In part D, they are telling me complete then the path of the ray BJ. Notice here that the ray BJ is an arbitrary incident ray in a sense that It's not parallel to the optical axis, it's not passing through the optical center O, nor passing through the object focus, because the object focus is the symmetric of f prime with respect to O. So in theory, we don't know how to complete the path of this ray unless we know the image B prime of B. So notice that all the emergent rays emerges as if coming from the image B prime, and this ray also, the emergent ray, emerges as if coming from the image B prime, and with no exception, the emergent ray corresponding to this ray Bj will emerge as if coming from the image B prime. Here in the question they told me complete, so no need to justify, but it's better to justify. So now in part D, first let's do the tracing. So if we connect B prime with the point J to be dotted, so the emergent ray corresponding to this incident ray will emerge as if coming from B prime like this. And we don't forget arrows on light rays that indicate the direction of propagation of light. Now let's do the justification. All incident rays issued from B emerges as if coming from B prime. So this is it for part D. Now in number 3 they are telling me characteristics of A prime B prime. So the image A prime, part A, the image A prime B prime is virtual Y. So notice that the object AB is pointing upward and the image A prime B prime is pointing upward, which means that the image and the object are in the same direction, which means that the image is erect with respect to the object. So since it is erect with respect to the object AB, then the image A prime B prime is virtual. One could give another reason why the image is virtual. So notice that the object and the image are on the same side of the lens, which is in front of the lens, and whenever the object and the image are on the same side, this means that the image is virtual. So let's say that since the object AB and the image A prime B prime are on the same side, then the image A prime B prime is virtual. Now in part B they are telling me determine the length of A prime B prime and its distance D from L. So the length of A prime B prime means the size of the image A prime B prime. Now A prime B prime consists of 3 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis. This will give us 6. Since the scale in centimeters, then the value of A prime B prime will be in centimeters. So A prime B prime is equal to 6 centimeters. And now it's left to calculate the distance. It's distance D from L. So here the distance D represents the distance between the lens and the image. So distance between L and A prime B prime. This distance is denoted by D. So this is the lens, this is the image. This distance consists of 1, 2, 3, 4, 5, 6 divisions. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give us 12. Since the scale is in centimeters, then the value of D will be in centimeters. So D is equal to 12 centimeters. So now we have reached part 4. They are telling me role of L. So what is the role of L in this situation? Why? Always the role of the lens can be determined from the properties of the image. So first of all, here the image is virtual. And the image A prime B prime is larger in size compared to AB. So it is larger. And whenever the image is virtual and larger, this means that the role of the lens is a magnifier. Then let's say since the image A prime B prime then L plays the role of a magnifier. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.